Hey everyone, so welcome back to another update of the game engine. So we're still working with Vulkan, and in particular I've been focusing on uniform buffer memory, okay? Because in the previous update what I had was basically a really naive way to handle uniform buffers, and we can actually still see it here, right? So I had this really generic create buffer function that I use for everything, for meshes, etc. But it was not really good also because every time I needed a buffer, it would create one as a single allocation. Uh, and if it's a buffer that I needed to update every frame, I need to buffer those. Otherwise, I'm modifying the same buffer in flight, which was not really a big deal because I had a really fast refresh rate. In this case, I was not syncing, but I need to buffer those allocations or those modifications as well, the same way I do it for the DX12 engine. But the X12 engine still was single allocations, so I decided to do it better. So let me show you first of all. So if we run Vulkan, right? So now we have a custom buffer pool, right? Where basically I can see all the different allocations. So there was a 6 megabyte allocation. This is a series of small allocation. For example, the 240 bytes is the actually only allocation I really need, and it's the camera buffer basically. All the other are basically dummy allocation. You can see here there was the allocation removed. All those are basically dummy allocation to see if everything works, right? And I can keep track of the memory pool size and everything. Actually, this is a bug. This should be 32 megabytes. So it looks like it's not converting to megabyte correctly. I'll fix that later. But anyway, so that's what I have, right? So everything is still working fine, and all the allocation are going through that. And how does it work? So the first thing is I needed to be able to allocate a big chunk on the GPU, which is no big deal, but then I need to swap allocate for that. So I need to know what is free, what is used, and the way I ended up doing it is by creating a class which is called linear buffer manager. So basically given a buffer, keep track of the allocation. Every time I want to allocate something, it's gonna find me a free range that can fit my allocation and return it to me as an offset from the start and a size. Okay, so it doesn't actually touch memory whatsoever. It just keeps track of it, and that works really well for GPU memory, which you don't really have direct access to, right? Also because previous allocator, which are similar, they actually store memory directly. For example, to keep track of the free allocation, I will store a linked list directly into the buffer itself, which I can do here, right? So what it does, it keeps track of the allocation I made and the free allocations, right? And also then I can access that later, and this is the data I use for rendering the pool, because once I know all the allocation, also I keep the allocation ordered, and I reuse the free allocation, I can easily render them, see how much is allocated. I actually know if I'm using the full allocation or a subset, so I know how much memory I'm wasting. Let's say, for example, I made a 2 memory allocation, 2 megabyte allocation, then I free it, then I make a 1 megabyte one. Most likely then 1 megabyte one is going to reuse the old 2 megabyte, and I'm going to have a waste, right? So it's a simple allocation strategy. You can have it in different ways, but this is going to work fine for now. I don't foresee allocating often, but there is the chance to do it. So once I have that, I actually created a constant buffer manager which allocates what I call a slab. So let's say a 32 megabyte slab, and then I'm going to allocate 3 of them or 2 of them depending on how many in-flight frame I have. So once I make an allocation, I can request a buffered allocation, right? So there is a series of flags that you can have. Not all are supported yet, but for example, buffered is one. So basically say, hey, I need to have a copy for every inflamed write, and also like if it's updated every frame, it's actually take a fast path because I know you're going to update that every frame. I don't need to copy into the buffer allocation as well. So there are a lot of logic which lets you handle allocation efficiently, but basically once you allocate, it's just going to, let's see, allocate buffer here, it's just going to the from the slab and basically say, okay, tracker, give me an allocation, and that's it, right? Then there is some extra bookkeeping here to keep track of everything, and just return a constant buffer handle. So a handle is an opaque handle, so the user is not going to deal directly with specific Vulkan memory, which is really good also for API abstraction. So I have this handle, right? For example, this is the camera buffer is buffer and buffer every frame. Then I can use this handle to perform an update and also a free, right? So it's completely abstracted away, and there is no specific API use. So I'm quite pleased with it, as the first time I was doing something like that. It's a lot more sophisticated than what I have in DX12, so at one point I will need to update the DX12 as well. So this is it. That's the only thing I wanted to show. So see you in the next video.